Hello, this is Patrick Jackson, and this is the fifth installment of the 8080 assembly code tutorials. And today we're going to be doing ATOI, which is a pretty awesome function. It converts ASCII to integer. You know how it works in C. But it took me quite a long time to even attempt to try to figure out how to do this. Sounds ridiculous, but it was mostly multiplication, efficient multiplication. And there was this guy on Reddit who came in clutch and gave me this routine. And today we're going to implement it. But also, as sort of a slight change to this video, I'm going to write a C program, and we are going to turn that C program into CPM 8080 assembly, and we'll compare and contrast exactly how difficult is it to program in assembly. And spoiler alert, it's not hard at all. So let's get started. So let's go right in here. ATOI is from stdlib. Okay. Now let us do. Let us set up some things here. So let's do char well text equals input number char digits. That's going to be how big. Char digits is going to be where we want to type our string into. Let's do 16 for size for buffer. Okay, so our first thing will be put s well text, and then we want to do get s. We're gonna get string digits. Okay, so we have now put input number, and we are now going to grab the user string. Now let's do if ATOI digits is not equal to 120. Let's just say we're going to test see if it's 120 or not. If it's not equal, then put s no text and return. But if it is equal to 120, then you're going to do put s yes text and return. And what is no text and yes text? Those are two things that appear. Char yes text equals yes. Char no text no. Jesus. Cool. And I think that's it. Main.o, main.c. Yes. And let's type in 121. No. Okay, we are going to turn this code into 8080 assembly. But first, let us figure out how to do ATOI in 8080 assembly. So let's start. Let's start by first we have to load the string to DE. Okay, then we're gonna do the counter. Let's just say the counter here is 5, but don't worry, that'll be a that'll change in the actual code. And then of course set HL to 0, because that'll be the return. And let's do this. There we go. Move C to A, A, and then JZ end. However, we want to do RZ, so return of 0 if C equals 0. Cool. And if it doesn't, push B. Okay, BC. Call mul10. Multiply HL. So this will be HL times equals 10. And you're like, well, what is mul10? Mul10 is down here. And mul10 is actually very easy. It's save B, move HL to B, C. So, sorry, B, C, move L, and then double add HL, double add HL, double add BC, double add HL, and then pop B and return. So this is HL times equals 10. It's a very short way to multiply a 16-bit number, which is pretty dope. And then once you have multiplied the number, you want to LDAX-D, load DE, right? And then SPI30H, convert it to int. Then to counter. XRA equals 0. Then move A to B. BC equals, what's that? DE minus ASCII 0. Double add B. So then, again, because you multiplied HL by 10, you want to stick the new digit on the end. Then you increment D. Pop B. And move up. Decrement the counter, right. And then jump back to ATOI plus 1, 2, 3, 4, 5. Cool. That right there is ATOI in 8080 assembly. Cool. Now, let us see if we can just make something of this. Let us make this program, this C program, in 8080 assembly. Let's get started. Now let's see if this even assembles. Well, didn't quite work the way I wanted it to, but probably just me needing to figure out exactly how to do things like that. Let's try again. Okay, that works. Look at that, we have ATOI in 8080 assembly. And honestly, it really isn't that hard once you have it written out. So we have figured out how to turn so we have figured out how to turn this C program into this 8080 assembly program, which is extremely small and very efficient. We figured out how to do subroutines for put s, get s, ATOI, and also multiply by 10. And that there is ATOI in 80 assembly. In the future, I'll be looking at ITOA in 80 assembly, and that would be pretty awesome. And until then, see ya.